All right, so today we are going to be talking about 7.6, which is kind of like pulling together a lot of the stuff we've talked about in chapter 7 in some application-y type problems. So, everyone's favorite. And without further ado, let me share my screen. So today, 7.6, rational equations and problem solving. So part 1 is solving equations with rational expressions for a specified variable. So this is like when we have equations that have a bunch of different variables. And this is applicable in, what comes to my head is chemistry, because chemistry has a lot of equations that have a lot of different variables. Like the one I'm thinking of is PV equals nRT, which is talking about like pressure, volume, that type of thing. Physics has mass equals force times acceleration, that type of thing. Like an equation where you might have a ton of different variables, you're given a few values and you need to solve for one thing specifically, like maybe temperature or volume or whatever it is. So basically, these problems are taking what we did in 7.5 and applying the same concept to equations involving only variables. So we have some general steps, and you can read through those if you are someone who learns better by like reading, but I'm going to go ahead and just jump right into the example. So we have solve 1 over x plus 1 over y equals 1 over z for z. Okay, so 1 over x plus 1 over y equals 1 over z, and we want to solve for z. So the first thing we're going to do, just like what we did in 7.5, is that in order to solve for a variable, we need to get them all out of the denominator. And in order to do that, we know that we're going to multiply our whole equation by the least common denominator. So the least common denominator is going to be the product of all our unique factors. So I'm going to list those out. My unique factors include x, y, and z. So I'm going to multiply by x, y, z. So then when I go ahead and distribute that guy out, I'm going to get x, y, z over x plus x, y, z over y plus x, y, z over z. I can do some cancellation fun now. X's are going to go ahead and cancel for me, not erase, cancel. Y's and z's. So I end up with my equation becoming yz plus xz equals xy. And now I want to go ahead and solve for z. And so in order to do that, I'm going to need to isolate that variable in particular. If I look at the left side of my equation, I can see that both of my terms contain a z. So I'm going to go ahead and factor out a z. And I'm going to be left with y plus x equals xy. And now that that z is isolated, I can go ahead and just divide by what I have left, y plus x. And then I know that I'm going to get z is equal to, I'll write it in a different color, ran out of space there, z is equal to xy over y plus x. Okay, so this is the same thing that we are doing when we have, when we were talking about 7.5, except for now we are solving for a variable that among other variables instead of a variable among other numbers. So same thing that we've been doing, but now it's just a little bit of a twist because that will help us apply it in other subject areas because math is everywhere and it describes our world and it's beautiful. Anyway, part 2 is solving problems modeled by equations with rational expressions. So there are some type of application problems that require us to write and solve a rational equation in order to solve. So for example, number 1, finding an unknown number. So we are told these type of problems are big on like standardized tests and stuff. But if a certain number is subtracted from the numerator and added to the denominator of 9/19, the new fraction is equivalent to 1/3. Find the number. So we're going to have to translate that word sentence into math. So we know that if a certain number, I'm going to call my certain number x, is subtracted from the numerator of 9/19, so 9 minus x, subtracted from the numerator, and added to the denominator. So that's going to be 19 plus x. The new fraction is equivalent to 1/3. Okay, find that number. So now I've translated my statement into math, and I have to do now, and what I have to do now is solve for x. So what I'm going to do is multiply through by the LCD. So my LCD is going to be the product of unique factors, which include 3 and 19 plus x. So times 3 times 19 plus x. So I'm going to get 9 minus x times 3 times 19 plus x over 19 plus x equals 3 times 19 plus x over 3. Get to do some beautiful cancellation magic. And I end up with my equation becoming 9 minus x, or 3 times 9 minus x equals 19 plus x. So that's going to be 9 times 3 is 27 minus 3x equals 19 plus x. Okay, let me give myself a little bit more space to solve here. So now I'm going to add 3x to the other side. 27 equals 19 plus 4x. I'm going to subtract 19. 27 minus 19, I should know on the top of my head, but 27 minus 19 is equal to 8. So 8 is equal to 4x, divide by 4, and I get x is equal to 2. And then when I plug that back in, it does not make any denominator 0, so my find an unknown number is in fact 2. Not too bad, you just have to make sure you're reading the problems carefully and rewriting them in math correctly, which is hard to do, and I realize that, but that's kind of the key to these type of problems. All right, next up, we are calculating homes heated by electricity. So in the United States, 8 out of every 25 homes are heated by electricity. At this rate, how many homes in a community of 3,600 homes would you predict are heated by electricity? And so what we are going to do is we are going to read the problem and then again, translate it into math. So we know that 8 out of every 25 homes are heated by electricity. Okay, so we know 8 homes are heated by electricity out of 25 total homes. And we want to set that equal to the number of an equivalent kind of fraction, right? And that's called a proportion. And I'm going to go back in these notes and type out the definitions. But a ratio is the quotient of two number or two quantities. And since rational expressions are quotients of quantities, rational expressions are ratios also. A proportion is a mathematical statement that two ratios are equal. So we're going to have 8 over 25 equal to x number of homes over 36,000 total homes. And then the way we can solve this ratio is by cross multiplication. So what we can do is we can say that 25x, so you multiply up and over, is equal to 8 times 3,600. And you can do this in either way. You can write 8 times 3,600 equals 25x or vice versa. But what you're doing is you're multiplying and then x across your equal sign. And then you know that 25x equals 8 times 3,600, which is equal to 288,000. And then divide by 25 to get x. X is equal to 11,520 homes that will be heated by electricity out of the 36,000 total. So nothing too bad here. Basically just applying, again, things that we have already learned. So problem set is posted. If you have questions, feel free to email me. You guys know the spiel. And have a great day.